Identifying the open intervals on which a graph is increasing, decreasing, or constant. If we trace the graph of the function from the left to the right, we always from the left-hand side of the graph toward to the right-hand side when you are looking for the increasing or decreasing interval. So from the left to the right, and the value of f of x increases as shown in the figure, we say that the function is increasing on the interval from a to the b. Your left-hand side, this is the a value, and the right-hand side is the b value. They are looking for, during this interval, from a to the b, how does the graph acting? So when you look at the curves of the graph, from the left-hand side, I trace the curve. It just continues to increase. So the interval from a to b, we call that is the increasing on the interval, increasing. If the value f of x decrease from a to the b, your a, x-axis, a is here, b is here. So from the left-hand side of the a on x-axis toward to the right-hand side of the b on x-axis, during this interval, the function just decrease, right? They just continue to going down. So we call this as a decreasing interval. When the function during the a and b, they just remain on a horizontal line. So there's a flat, it's a constant line. So we call the interval between a and b is a constant on the interval. Now we look at this graph. State the open interval on which of the function is increasing or decreasing. Let me change your color here. So start from the left-hand side of the graph. The left-hand side is here, right? So when I trace the graph based on the curve they have here, it's an increasing interval. When it comes to the -2, x equals -2, it changed the direction, changed to the decreasing interval. Then when it comes to the 0, x equals 0, it changed the direction to the increasing interval. And after that, when x equals 2, after x equals 2, the graph changed the direction to the decrease interval. So your increasing interval of this function has a negative infinity, right? Increasing interval, we are looking for the x value. So since the end of the curve on the left-hand side here, it gives us an arrow. That means it will just keep going to negative forever. So the increasing interval will start from negative infinity, come to this point, which is -2. Another increasing interval is from 0, x equals 0, up to x equals 2. So we put a 0, 2. The decreasing interval, same way, we are looking for the x value. So the decreasing interval is from x equals -2 up to x equals 0. So we write down the -2, 0. Another decreasing interval is from 2 go to infinity. So you'll have the 2, infinity. Two components you need to understand when you represent the increasing or decreasing interval. Number one, they always go with a parenthesis when you represent the increasing or decreasing. No bracket for the interval when you represent the increasing, decreasing. Number two, you are looking for the x-axis. that would be the value you are going to put into the interval. Represent from the left hand side point to the right hand side point, from the left to the right during that interval on the x-axis. Is finding the local maximum and the local minimum. We call the y value of the high point. The high point is this point. We call this as a local maximum. We call the y value of a low point is a local minimum. Keep in mind, when you hear the words local max or local mean, they all associate with the y value. Locate the local maximum and the local minimum using the graph of the function shown here. So we start from increasing, decreasing. Okay, when you determine the increasing or decreasing, you're always from the left hand side of the graph. So when I click on the when I trace the graph from the left hand side of the graph, so I start from the left hand side, it tells me it's a decreasing, then increasing, decreasing, increasing, decreasing. So from the left to the right. How do you represent the interval for the increasing and decreasing? Increasing interval is from C1, C2. C1, C2. That they are your x value, right? Another increasing interval is from C3, C4. For the decreasing interval is from negative infinity, because this arrow just gives us the information, is negative infinity. So your decreasing interval is from the negative infinity up to C1. That would be the decreasing interval. Another decreasing interval is from C2 to C3. So C2, C3. Then from C4, go to past infinity. That would be another decreasing interval. Again, increasing, decreasing, you always from the left to the right of the curve, and you are looking for the x value. Now, local minimum, I mean this point, right? There are two local minimum because this is a polynomial function. So you might have more than one local point. So the local minimum of this point, that would be this value. For example, if this is 2 and this is 1. So the local minimum of your point C1 would be 2. And now the local minimum point, this point, would be just 1. Local max, we have two local maximum points, right? So for example, this point is, let's say, 5. Another point is 5.3. So this point, f of C2, will be equal to 5. Another local maximum is 5.3. So finding the local mean, local max, you just need to go target the highest point or the lowest point based on the question asking for it. But you look at the y value. Now we do this example from the web design. You need to identify the local max and the local mean. I will do both, increasing, decreasing, and the local mean, local max. So increasing interval, decreasing interval. From the left hand side, we trace the curve from the left hand side. So it's going down, which is decreasing, decreasing, decreasing. Then it changes the direction to increasing, and then change to decreasing again. So the increasing interval only from here to here. Look at your x value. At this point, the curve changes the direction at x equals 0. So from 0 up to this point, which is 2, that would be the increasing interval. We only go with the parenthesis to run the interval that represent the increasing or decreasing. For the decreasing interval, it's from the left-hand side, negative forever. So your decreasing interval is negative infinity, comma, up to this point, which is 0. Another decreasing interval is from 2 to the positive infinity. So you have the 2 go to the positive infinity. Local maximum, this is a local maximum. How can you find a local maximum? Look at your y value. At this point, your y is equal to negative 2. Local min, local minimum. Sorry, let me start over. This is a local minimum. Finding the local max, this is a local maximum. So this is negative